Hello, everyone, and welcome to today's session titled Innovations in Public Works. My name is Megan McSween, and on behalf of the Ottawa Valley branch of the Ontario Public Works Association, we're happy to have you join us for our first of 3 sessions in celebration of Public Works Week. We have a special guest here to provide opening remarks, so I'm going to keep this brief with just one quick housekeeping item before we get started. We will have a few minutes for questions after each presentation, so we ask you to please use the Q&A button at the bottom of your screen as opposed to the chat box to submit your questions. And with that, I'm going to pass it over to the past chair of the Ottawa Valley branch, Amanda Shane.
Thanks, Megan. Welcome, everybody. I have the honor of introducing Kevin Wiley, the General Manager of Public Works Environmental Services at the City of Ottawa, to be our keynote speaker. Kevin is the General Manager of Public Works and Environmental Services Department, PWESD. The department offers services that are deeply connected to communities and play a key role in the lives of residents by operating and maintaining municipal infrastructure and delivering services to protect the environment and the health of our residents. PWESD is an exclusively operational department with a focus on quality frontline services and client satisfaction. Kevin has over 38 years of municipal experience, starting his career in local government with the City of Toronto. While with the City of Ottawa, Kevin has gained experience through managing many operational service areas prior to becoming general manager, including units within solid waste, traffic operations, and roads. Kevin is a dynamic leader and a strategic thinker with in-depth knowledge of municipal operations, service delivery strategies, and strategic planning. He is a champion of client service and is committed to the city's priorities and overall goals of service excellence. So on that, I will have Kevin come up and provide his address. Thank you.
Well, thanks, Amanda. And thanks to the Ontario Public Works Association for inviting me here this morning. And happy Public Works Week, everyone. And a special thanks to Megan and Amanda for your hard work in putting this event together. This week is all about energizing and educating the public on the importance of public works in their daily lives. This feels particularly important given how deeply the COVID-19 pandemic has forced changes in our daily lives and the way we deliver our services to our community. Over the past year, or 16 months, with more people working from home, our experience at the City of Ottawa has been to put a focus on our services. We have seen increased tonnage of across all of our waste streams, increased uses of paths, parks, sidewalks, cycling facilities, and with it, of course, a higher demand for services like litter pickup and snow plowing. We've also seen a focus on our water services, and we're proud to provide data to the University of Ottawa for wastewater COVID-19 surveillance, which has played an important role in monitoring COVID in our community. And through it all, Public Works and Environmental Services team at the City of Ottawa has adjusted quickly. Leaders ensured their teams had the tools, the support, check-ins required to function effectively and safely. Looking back over the year, I'm amazed at their ability to pivot over and over again. They never missed a beat, and our staff answered the call when asked. From transforming virtually overnight to run our seasonal transition and our leadership training programs to an online platform, and all the while simultaneously balancing their home life, including staying connected with friends and family, and also keeping their team safe. And of course, for many of our team members, the biggest challenge, trying to figure out how to entertain and educate kids from home. As a member of Ottawa's Public Works and Environmental Services Department, it is truly inspiring. And I'm happy to share some of our experience, response, and innovations during these challenging times with you today. Our top priority, of course, during COVID-19 has been and continues to be the health, safety, and wellness of our staff. We quickly adopted to shifting priorities and doing work differently. This included securing personal protective equipment, creating signage, separating essential staff into different cohorts, shifting start and end times, getting staff the necessary equipment to work from home, and calling in support as needed for planning and innovation. To this day, we continue to adapt, evolve, and respond to changing information as the pandemic evolves, as I'm sure you can all relate to. PWESD proudly and professionally continued operations, from treating our water to waste collection to keeping our parks clean and our roads safe. And to do this, we developed continuity of operations plans. These plans ensure that the service areas can adapt to changes to the city and provincial regulations or restrictions, including positive cases from our staff, and we've had a few positive cases, self-isolation measures, and more. The continuity of operations plans have really been our playbook as we continue to review them and update them bi-weekly. The emotional and mental health of our teams is also a top priority, as we all cope with the added stresses of COVID. In the fall of 2020, we were proud to have launched our departmental peer support network pilot program. The peer support network is a team of 25 trained staff volunteers from across the department who are prepared to provide confidential social and emotional support to their coworkers. Peer support is not a replacement for professional medical or clinical care. It is, however, a complement to the other wellness resources available to employees. And the volunteers receive training designed to help them support their colleagues. Staff can contact a peer supporter in person, of course, adhering to COVID protocols, by phone through a confidential phone line, or by email. We've seen a great response to the network, and we're working to make it permanent. We've also leveraged innovation during COVID-19. All service areas were not only creative, but supportive in developing new ways of doing things. While challenged to accept the new normal and changes at work, they did it seamlessly. We launched an innovation challenge for the department, asking staff to put forward their ideas how they could deliver their services in new ways given our current environment. We had a great response to the challenge with so many great ideas, but also highlighting many of the things that were already happening in the department. I'd like to share a few examples of some innovative solutions that stand out for me over the past 16 months, sorry. We've seen so many shifts to paperless and mobile solutions. In many ways, COVID is the push we needed to speed up that implementation. The biggest undertaking in this regard has to be transitioning our master assignment board to a virtual process. Our master assignment board is how it sounds. It's how our staff, our operational staff, select their work assignments twice a year with the summer and winter operational changes. The event is normally held in an arena with over 200 people. The team pulled together and created an online system to make this 100% virtual. It's now been run virtually twice with great success. Another example of innovation is from our water team. The pandemic has challenged staff to rethink the way they collaborate, given the need for fewer on-site staff. Their solution, smart glasses, or as they like to refer to them as spy glasses. Using audio and video feed in the glasses, water services employees in the field can connect remotely to others and share what they're seeing, download documents, provide on-the-job training, and capture images. This technology has allowed the team to work more efficiently and safely without sacrificing collaboration. It has been amazing to see how creative staff have been and how well they've adjusted to the continual change, the ups and downs of the pandemic. And finally, I think our experience in Ottawa with Public Works rising to the occasion and ensuring services run smoothly and staff are safe is just one example of the many of the Public Works colleagues across the province. And with that, have a great Public Works week, and I look forward to the sessions. Thank you.
Thank you so much for that, Kevin. It really is impressive how quickly everyone adapted to dealing with COVID in order to keep the Public Works we rely on operating. So we really appreciate you taking the time to be here this morning and helping us kick off Public Works Week. Okay, so now we're going to jump right into the presentations. First up, we have Darlene Conway and Amanda Lynch from the City of Ottawa with their presentation, Pinecrest Creek, Rehabilitating an Urban Subwatershed. Darlene Conway is the Senior Engineer for Stormwater Management Projects in the Public Works and Environmental Services Department of the City of Ottawa. She has practiced professional engineering for 30+ years, focusing on stormwater and floodplain management in both the private and public sectors. She has worked in consulting for 2 conservation authorities in Southern Ontario and for the last 19 years at the City of Ottawa. She led the city's early efforts in stormwater management retrofit and low-impact development approaches. Her current work focuses on providing engineering support to the maintenance, operation, and rehabilitation of the city's 230 plus stormwater management facilities. Amanda Lynch is a senior project manager at the City of Ottawa. She's an experienced water resources engineer involved in a range of projects related to stormwater infrastructure planning and design, floodplain mapping, and policy development. Through her projects and other initiatives, Amanda is actively working to develop policies, plans, and procedures and tools to improve the resiliency of our growing city. So I'll pass it over to
Okay. Good morning. Good morning, all. My name is Darlene Conway, and I and my colleague Amanda Lynch will be speaking about a range of efforts that have been going on for the last 15 years or so to rehabilitate a small urban watershed in the west end of the City of Ottawa. I'm going to be providing some historical context to these efforts and focus on the work that's been done to date, basically the past and the present. Amanda's going to be speaking to the future and what's next regarding medium and longer term efforts. But just in case anyone's wondering, why are we talking about a creek at a Public Works Week? Roads, sewers, and stormwater management facilities are all recognized as public assets that provide drainage and manage runoff. Stormwater management in particular facilitates new development by mitigating the impacts of uncontrolled runoff on receiving watercourses. But what about the creeks themselves, particularly in older areas like the Pinecrest Creek Subwatershed that developed before the advent of stormwater management? These watercourses and their corridors can also contain significant infrastructure assets, outfalls, manholes, bridges, culverts, SANI and water main, undercrossings, transit, recreational pathways, you name it. As decades of uncontrolled runoff take their toll, this infrastructure can be threatened by increased erosion, slope instability, flooding. Focusing on the imminent threat and spot treatments like hardening, creek enclosures, channelization has not proven to be an effective approach, often creating additional problems down the road. So this is just a plug to remind all that urban creeks are also public assets that require active management. Condition assessments that consider the creek as a whole, its natural form and function, subwatershed scale studies that identify priorities and opportunities to implement stormwater retrofits, as well as capital that is in-stream works when required to protect threatened infrastructure while working with the creek to the extent possible rather than against it. This approach has been and is being applied to Pinecrest Creek and its subwatershed. So to locate ourselves, Pinecrest Creek begins near Hunt Club Road in the south and ends at the Ottawa River. It has a small subwatershed of about 1,440 hectares. Today, only a small stretch of open channel remains between Baseline and Carling, about 2.3 kilometers. It's shown in blue on this figure here. Above Baseline, the subwatershed is completely sewered. Below Carling, the creek is fully enclosed until it meets the Ottawa. In between, about 7 major storm outfalls discharge to the open portion of the creek. Subwatershed is one of the most urbanized in the City of Ottawa with a percent imperviousness of about 36%. This is very high compared to what would have been a forested condition prior to the agriculture that transformed the area by the late 19th century. The subwatershed was built out almost fully by the late 1990s, and the remaining open creek exhibits all of the effects of decades of uncontrolled urban runoff, including poor water quality, ongoing erosion, and high peak flows. So while the city owns and operates the storm sewer networks that outlet to the creek, The creek corridor is owned by the National Capital Commission, with little or no stormwater management included when this subwatershed developed. The creek has been adjusting, in other words, widening, downcutting, moving within its corridor for decades. In response, the NCC completed a restoration plan in 2007, an integrated master plan to improve the creek's degraded condition by making use of natural channel principles. Effectively, the restoration plan recommended a series of in-stream rehabilitation measures. So these in-stream works were necessary to protect infrastructure. For example, the NCC pathway that you see in the middle panel, lower middle panel. But they were also designed to help the creek better manage the uncontrolled peak flows that existed. If you look to the panels on the right, this work was done to reestablish a narrower low flow channel by creating a small floodplain beside it, while conventional erosion, hard erosion protection was used at the base of the slope to protect the transitway located just beyond the top of the slope. You don't see it in this photo. So following on the NCC's restoration plan, the City of Ottawa completed the Pinecrest Creek Westboro Stormwater Management Retrofit Study in 2011. This was a subwatershed scale study that complemented the NCC's in-stream efforts. In contrast to in-stream measures, the retrofit study focused on how to effect change in the subwatershed's existing hydrology, in other words, its runoff response, by developing a long-term plan to implement stormwater retrofits at all scales to manage peak flows, reduce runoff volume, and improve water quality. Recommendations include measures at the end of pipe, within the right-of-way or conveyance, as well as at the lot level. Since 2011, a number of these retrofit projects have moved forward. So the first one I'll speak about is an end of pipe example. It's the Baseline Woodruff Stormwater Retrofit Pond located at the northeast corner of Baseline and Woodruff, and this is on NCC property. This project represents the first major step in the retrofit plan. The pond was designed in partnership with the NCC to meet the objectives of benefiting the creek, as well as creating a community amenity. It will treat runoff and reduce peak flows from 435 hectares, which is about 20+% of the total subwatershed area. Its size is expected to have a great impact on the creek, provide major benefits in terms of reduced peak flows and improved water quality. So the next example of a retrofit we are currently implementing is within the right-of-way or a conveyance retrofit. This is the Hemingwood Way bioretention bump outs that began construction last year. They are anticipated to be completed this summer. They are an example of a low impact development retrofit, which will capture the road runoff and adjacent boulevard and treat that through biomedia, through a gravel reservoir, through infiltration, and then discharge to the storm sewer. And finally, in terms of the different types of retrofits that are being implemented, the retrofit study identified the importance of reducing runoff at the lot level from private property as well. This was necessary given that in the case of Pinecrest Creek subwatershed, residential development represents some 40% of the total subwatershed area. In response, earlier this year, the city launched a 3-year pilot program to encourage and support residents to take action to reduce runoff from their properties. So this will include a number of efforts, including providing information, training, home assessments, community engagement, and a range of financial incentives. So finally, how will we know if progress is being made with respect to the objectives of a healthier creek, reduced flooding and erosion threats, improved water quality? We know that the creek will continue to respond and adjust to current and future stressors, like, for example, stage 2 LRT, which is currently under construction, ongoing infill and redevelopment that will occur, as well as the responses that we take to mitigate these ongoing and future impacts, like the pond I just told you about, and implementation of other stormwater retrofits. So to assess these benefits of the retrofits, as well as the impacts of other stressors, the city will be implementing an integrated monitoring plan starting in 2022. Monitoring components will include water quality, temperature, stream flow, fluvial G, benthos, as well as watershed imperviousness. So that is just a very quick overview of what's been going on for the last 15 years or so, up to the present. And so I'll just hand it over to Amanda now to tell you some more medium and longer term efforts.
Right, thank you, Darlene. I'm going to switch. All right. So thanks for that brief but great summary of the work completed so far for Pinecrest Creek. As Darlene noted initially, I'm going to give also a brief overview of some of the tools and guidance that we have prepared for moving forward with the implementation of retrofits within the Pinecrest Creek subwatershed, but as well the broader city of Ottawa. And I'll also highlight some of the ongoing stormwater retrofit planning work and some of our next steps. So Darlene noted the Hemmingwood Way bioretention retrofit as an example of an LID swim retrofit within a city right-of-way. And this type of retrofit project is most cost efficient when it's completed as part of a planned road reconstruction project. To coordinate this effort, though, we needed a way of identifying road projects that were suitable for retrofits within the Pinecrest Creek subwatershed, but also within the city of Ottawa as a whole. However, due to the high number of road reconstruction projects and frequent changes to capital work schedules, a tool was needed for efficiently screening and prioritizing opportunities. As such, the LID screening tool for municipal right-of-ways was developed. So this tool identifies areas where the implementation of LID measures will be most beneficial, as well as some areas where maybe they should be discouraged or not implemented for various reasons. It is a fully automated GIS-based screening tool, which aids city staff to conduct systematic reviews of a large number of right-of-ways on a regular basis. And the output of the tool is a list of candidate projects that demonstrate potential for the implementation of LID measures. The screening tool applies a three-step process, of which two are GIS-based, and the third is a more manual screening process. So step one uses available GIS data from the city's databases to review subwatershed health metrics and identify priority areas for retrofit projects. So those areas where there may be the most benefit experienced with implementation of retrofit. Step two references the road reconstruction projects identified in the city's 5-year future capital construction plan and screens these against several other GIS data sets that may represent constraints or opportunities and would influence the suitability or performance of LID measures. These results are then prioritized based on their location and the results of step one. Step three works with the list of priority projects and uses a spreadsheet tool with inputs from field assessments to further determine the most suitable type of LID measure to be implemented. And the overall intended outcome from this tool is to increase the success rate for integrating swim retrofits into road reconstruction projects by identifying opportunities in advance of the planning and financing for these projects, for the road projects. So some additional pieces of ongoing work are the development of guidelines, policies, and plans which serve to identify design guidance to ensure proper performance of an LID feature, set requirements and expectations, and define the path to broader implementation of swim retrofits across the city. With respect to guidelines, there is a lot of LID guidance available now that's been developed by various agencies throughout the province of Ontario. However, the extent and variability of hydrogeological conditions across the city of Ottawa has presented some challenges for the design of LID measures that is not always captured in some of the available guidance. As such, we have prepared a guidance document for the city of Ottawa to support implementation of LID in areas with hydrogeological constraints. So conditions such as low soil permeability, high groundwater, and the list goes on. The document was prepared initially as a guidance document only, but the intent is to reflect its recommendations along with additional LID guidance in a new section of the Ottawa Sewer Design Guidelines. I do want to note that this guidance can be applied to retrofit projects for sure, but is intended to support all types of LID projects. In addition to guidelines, policies and strategies are identified in the draft new official plan, will be included in the infrastructure master plan and stormwater master plan, which will support implementation of existing retrofit studies. Additionally, the stormwater master plan is reviewing and prioritizing the remaining retrofit study areas within the city. We are also finalizing our first stormwater asset management plan, which identifies a high-level opportunity to leverage LID stormwater retrofits to address stormwater infrastructure renewal challenges and improve drainage levels of service. But what is the status of swim retrofit planning for the city of Ottawa, and what are these remaining study areas I was talking about? So the figure you see here summarizes the status of the swim retrofit planning. The green areas are those for which a swim retrofit plan has been completed. So we have Pinecrest Creek here and the Eastern Subwatershed study area, for which the retrofit plan was approved in 2019. The pink areas are the remaining study areas and are composed of subwatersheds with storm infrastructure discharging to creeks or streams, as well as sewer sheds with infrastructure discharging directly to the river. So the remaining areas are those that the Stormwater Master Plan is reviewing and prioritizing for future study. It is expected that the opportunities for and benefits of swim retrofits will vary for these remaining areas. So while a lot of work has been completed and is ongoing, there is still quite a bit of work ahead of us. A few key next steps for the overall stormwater retrofits for the City of Ottawa are to assess the results of the Rain Ready Ottawa incentives pilot and develop recommendations regarding a long-term program. And that will be based on observations, uptake, successes, challenges of the pilot program. We'll also be looking at integrating the screening tool into the city's infrastructure renewal program and processes so that we can make use of it in the most efficient way. We will need to develop an operation and maintenance program for the LID retrofits that we have constructed and will be constructing. We will have to complete additional retrofit studies following the recommendations of the Stormwater Master Plan and based on the prioritization it identifies. And of course, continue to implement retrofits within the Pinecrest Creek Subwatershed and the broader City of Ottawa to improve the health and condition of our urban watercourses and their corridors. So this concludes our presentation, and we'd like to thank you for your attention and the opportunity to present today. And we would be happy to answer any questions that you may have.
Thank you to Amanda and Darlene for a great presentation. Very, very good. Is there any questions? Could you please, if you have any questions, could you type it? I don't see anything coming. So ladies, thank you very much.
Thanks very much.
Take care.
Take care. Bye-bye.
Okay, thank you both.
Oh,
And yeah, if
Shannon.
anyone has some questions, please feel free to type them in, and hopefully we can get Amanda and Darlene to address those at the end. So continuing on, next up, continuing on the theme of stormwater management, we have Vivek Sharma to talk to us about stormwater management solutions, an application and a municipal setup. So Vivek is based in Toronto and has more than 23 years of experience in consulting, municipal engineering, and contracting. Vivek has a bachelor's degree in civil engineering and master's of business administration, and is a registered professional engineer in Ontario. In addition, Vivek is involved with various committees and organizations. Vivek is working with StormCon Canada, where he provides comprehensive technical advice in the selection, use, and application of stormwater management products for infrastructure projects in the province of Ontario and internationally. So I'll pass it over to you, Vivek.
Megan, I can't get my video started.
Okay, are you able to share your presentation? Maybe you can start with that. And
Okay, I'll bring it up. Good afternoon, everyone. Vivek Sharma from StormCon. Taking a leaf from Darlene and Amanda's playbook, I'm here to discuss stormwater management, macro planning kind of approach with key points on land use, optimization, and flood prevention, specifically in retrofit of existing and future infrastructure. StormCon works on quantity and quality side of the world, where basically we are treating the water, stormwater, and storing it underground. Case study number one we are talking about is Cooksville Creek watershed, 34 square kilometer of surface. You can see it in the green dotted lines here. And barely you can see any blue in there. That means no ponds, no way of conveying water overground. Everything is a sheet flow. And this is a 2013 video that is flooding on Quatra Lakeshore area. And that's a kind of regular feature. If I go back a slide up here, you can see on top of my screen, this is Lakeshore. A recurrence every year, all the catch basins and manholes are bubbling on Lakeshore all the time. How do we deal with these situations is possibly a proper management and planning is needed, where we can provide these underground storage systems in existing park facilities and reclaim the land at the same time. Something like what is proposed in here. This is Cooksville Creek phase 1, where we put an underground storage system right under the park area, existing park. You can see the houses in the periphery all around. And that's something like, this is a park, a ball diamond, right underneath is a storage system. Construction time is when we put these chambers in. These are 100% void underground, 5 meter deep to the top of the system. So the system was pretty much sitting at the 6 meter depth. Easy to construct. This whole project was completed in 3 months' time, storing roughly 14,000 cubic meters of storm runoff. We have similarly used these in applications where all these subdivisions are being built. The key areas are the new subdivisions do have a lot of overlap between the infrastructure and land is scarce. Specifically in all the urban areas, land is difficult to get by. So these provide a very interesting solution to the existing problem. But with the solution comes some problems too. We need to discuss those points as well. This is another construction site that we had where you can see the buildings are in the periphery, and these storage systems are built in right under a park area. They can be put in a parking lot or under the road. We have done a few projects where they've been used right under an arterial road in Halton region. Pretty quick and easy to install. The key part here is they are very much inspectable and cleanable, so you can maintain it. Our approach, as Darlene has been with CAs, conservation authorities, conservation and MNRs are pretty big on these things because they can be inspected, cleaned up, and can handle all the first flush that requires the treatment and cleaning. The benefits we can talk about is low carbon footprint, faster installation, easy maintenance. And the best part is groundwater recharge that is possible with these things. So my video, I'm barely visible. I didn't notice that. They can be driven on top, as I had mentioned. They have been used in applications where this road is sitting right on top. In right-of-way applications, they've been used, but this specific case in Oakville, where they have been used because of the space constraint right under an arterial 6-lane roadway. And the approach would be to clean up the system as well. We're looking at first flush, or I call it first bucket approach, where the first bucket on your driveway is the dirtiest water that you need to clean. Treatment train approach is what conservation authorities have been finding are a big fan of lately, because they want to see the treatment to be tackled at through multiple angles and approaches rather than one point approach that has traditionally been used. Treatment train approach, I would see that if you have a hockey team, you have not only the offense and the goalie, you have defense as well right in the middle. So that's defense mechanism. Concept is very simple. The first flush is diverted into a certain section, which basically acts like a 4-bay and can be cleaned and inspected at any given point of time. Rest of the cleaner water goes into the rest of the system. So it's a 4-bay and storage approach. If I had to look at the elevation, how would I create a 4-bay is keeping it low flows into a certain area, restricting into certain areas, and high flows can go into the rest of the system. Different applications we have seen, we can go real green LID features. You can use something like bioretention facilities and rain gardens. So we can work on 20 cubic meters and 20,000 cubic meters at the same time. We can have them replacing all the ponds, which is an interesting aspect of the game because ponds take space, very difficult to maintain, and it's cost prohibitive. Operation and maintenance, if you look at the playbook from MOE, cleaning up costs can range from anywhere from $250,000 to over $500,000. We cleaned up a pond on Highway 7 at Seneca College, and it costed city and region, city of Markham, north of $500,000. So there's a huge cost involved in cleaning the ponds, where these things are relatively easy to clean. All you need is a vac truck. We just wanted to share one more slide, and that is our oil grit separator that basically handles the grit and oil that is coming in from the first flush. Questions, concerns, and issues that we can always field?
Thank you, Vivek. It was a very good presentation, and it's open for questions. Is anybody there who has a question? Please, you can type it. Well, thank you very much and have a great day.
Thank you, Sandra. I see a question.
Oh, there is a question here. These are accessible for public works to clean?
Yes. Generally, all the public work departments have a flusher truck these days. If not, it costs about $300 an hour to hire a flusher truck. All we need is a vac truck. Vac can flush it out. How long would it take? In our experience, generally half a day to full day, depending on the size of the system we are looking at. A small system, roughly less than 1,000 cubic meters, can be done in a couple of hours. If example that I showed was approximately 15,000 cubic meters, it'll take about a day to clean it up.
How often do you need to clean them?
The cleaning frequency is generally 7 to 8 years. So we can do the calculation based on what kind of sediments are coming in. The approaches have been changing. So if I look at the northern part of Ontario, we still use a lot of grit for our salting and sanding operations, but Toronto area, we've been going into no sanding. So frequency will change depending on the location of these systems. But safely saying 7 to 10 years is a relatively good number.
Mm-hmm. Another question. How critical is the installation to ensure the integrity of the system? My concern is that if they are installed poorly, then you could have water movements below grade that could result in settlements or sinkholes.
That's a very good question. So the critical part is we have been replacing pipe systems with these things. I can pull up a slide where I can show it to you, or maybe I can share if you want. I can send the details over where we are replacing pipe. So pipe systems, what we are doing is duplicating our efforts in infrastructure. We have pipe conveyance system, which is generally designed for 5-year flows. And then we have 100-year storage systems, which is a pond or these newer alternative technologies coming in. So these things are designed such that there's bedding of stone. And these installations are more critical for the upside rather than the bottom side of these systems that have to have the settlements or sinkholes. So installation is important because anything that needs to be installed correctly or built correctly, we all know the importance of it. But they are designed to have the water movement below the grade. They can be designed not to have exfiltration, but they are designed for that purpose. So it's been tested. This technology has been in existence for almost 40 years now. It's just catching up when the land prices are going super high and infrastructure is critical because we have barely any space for putting these newer infrastructure for control of flooding and other aspects.
Another question. How the cleaning is done? Flushing with clean water?
Yes, correct. So all we're doing is flushing. I should have put in a video. So we put in the flusher truck, we flush it, sediments are agitated at the bottom, and they flow back into the control structure where they're sucked up or vacuumed out.
Is there any other question?
How much land area does a typical swim takes up in a subdivision? It's about 5% of the development is dedicated for land, for park, and 5% for pond. So these numbers are pretty much exact same numbers. And if we can avoid the duplication, we've been seeing a lot of traction lately in this area where you can have a pond and a park land together. saving precious land.
So it is just the one pipe that gets clean?
Pretty much just one pipe or one area, which we call forebay. That is, so all the dirty water or the first flush is directed into that area. So that we are not having we are not opening up multiple fronts to clean and not a larger area or multiple sections to clean out. So intentionally it's designed in such a way that only one area or one pipe is getting the dirty flows.
If there is an existing stormwater management, can you convert it while maintaining the stormwater needs? How do you do that?
Oh, that is a very good question. So yes, it is doable. Initially, what we'll have to do is build in the good part and the bad part. The way that things have been designed so far has been that the park and pond are two separate entities. So if you can somehow divert existing, so first build it in the park area, a newer facility, and then decommission it and connect it to the newer facility and take the existing pond offline, very much doable. Obviously, it requires a bit of engineering.
If cleaning is done once every few years, will there be any potential risk of sediment buildup in the system?
These are designed to have a buildup, and generally a couple of inches. When the sediment at the bottom is a couple of inches, reaches that point, we recommend it to be cleaned. So actually they're designed, they filter the water better when there is a film of sediment at the bottom.
So how
that is a media filter.
Okay.
How many projects have been done?
Yes.
So far, we have done at least 10 projects, including 2 in city of Mississauga, 1 in city of Markham, 3 in Windsor area, 2 in Embrun area, which is Ottawa area, pretty much. So we have over 20 installations for this application only. And ICI is where the focus was used to be. ICI, so industrial, commercial, institutional, there are thousands of applications that we can share.
Another question. Are these methods incorporated in municipalities globally?
The trend is catching up. We are seeing a lot of traction everywhere, and we see the growth in this market in a big way, where I mean, we are all aware right now, last year in pandemic times, 30% growth rate in property prices. Everybody's scrambling to find the land, where to build. God is not making any more lands.
How many of the projects have been done that are retrofits of existing ponds?
4 have been done. 2 are supposed to be commissioned this year, 1 in Vaughan and 1 in Mississauga area. So these are retrofits. We can share the details if needed, but City of Vaughan is working on 1 project this year, and 4 have already been built in City of Mississauga. 1 has to go in this year. And these are all municipal retrofits I'm talking about. I'm not talking about the subdivision and newer construction.
Well, that was a lot of questions. That was a good presentation. Thank you very much.
Thank you, everyone. Sandra, I have a question. In case anybody wants to reach out with a question later, is it possible we can share my details?
Megan, are you there?
Yep, I'm here. Yeah, if anyone has any questions, they can put their email address, I guess, in the Q&A, or send an email to the registration email address, and we'll pass them along.
Perfect, thank you.
There is Vivek, before you go, there is a question in the chat. It says, what is the lifespan? When it comes to replacement, what is the strategy to protect the system, temporary storage and treatment?
So I can answer it with one very simple statement that I live in city of Toronto and I pay 5 cents per plastic bag because plastic's half-life is about 400 years. Now, I'm not claiming that they last for 400 years, but half-life of plastic is roughly over 400 years. They're designed for 100 years lifespan on the peak with 2.8 factor of safety. So the design is done such that they last for 100 years.
That's it. No more questions. Thank you very much.
Thanks, Sandra. Thanks, everyone.
Take care. Bye-bye.
Bye.
Great, thank you. Yeah, and if there are any other questions, you can keep putting them in the Q&A, and we're running ahead of schedule, so if we have time at the end, we can certainly come back and look at a few more questions. Okay, so last but not least, we have Rob Carbone and Fraser Hahn to talk to us about drones and robotics and their application in engineering. Rob Carbone is a drone pilot and principal with SkyMax Drone Services. Rob has been with SkyMax Drone Services since 2015 and is a Transport Canada licensed advanced RPAS drone pilot with expertise in aerial inspection, photography, and videography. Rob's experience includes performing site assessments and planning for aerial missions, conducting aerial drone flights for aerial inspection, photography and videography, performing technical analysis of visual aerial data, and has over 1,000 hours of commercial flight experience. Fraser is the Director of Technology at RMUS Canada, which is a leading unmanned solutions provider. RMUS builds drones and have now evolved to drone fleet management, including equipment sales, operator training, and tech support. As a small unmanned aircraft system professional, he has broad experience in field operations, training, sales, and fleet management services.
Thanks very much, Megan, and to Sandra and the OPWA for having us this morning. So as Megan mentioned, I work for a company called RMUS, and basically we provide drones and robotic equipment to industry and government and contractors. Also training and consulting to go along with them. And we've, for a while now, been working very productively with Rob and SkyMax, so I'll let him talk a little bit about what they do.
Hello, everybody. My name is Rob Carbone, and I am the owner, founder, and chief pilot of SkyMax Drone Services. We are a Southern Ontario-based company that has flown thousands of missions all through Ontario's rural and urbanized areas. The services we specialize in is high-definition aerial photography, aerial videography, aerial inspections, confined space inspections, 2D, 3D, photogrammetry mapping, and lastly, volume calculations. The benefits of this data is that it can be collected in large areas in a fraction of the time as traditional data collecting methods. The data collected from these services can be highly useful for aerial images and obtaining accurate measurements for engineering firms, public works, civil infrastructure, road construction, and waste management. Some of these examples I will now let Fraser demonstrate in a video slideshow. Thank you, everybody, for attending.
Okay, so you've probably heard that drones are going to be everywhere soon, replacing all kinds of jobs, delivering packages, and all sorts of other neat stuff. I'm not really sure how realistic some of those things are in the short term, but as drones get more capable, we'll most likely be seeing lots of them applied to more and more jobs and more relevant jobs than we used to think would be possible. Okay, we'll talk more about that shortly, but why should we really care about drones? What are they? Why might they be useful in the workplace? So basically, drones are unpiloted aerial platforms of any kind. They carry stuff. Usually they're carrying cameras or other sensors. Personally, I find it unfortunate that these potentially amazing tools share a name and some of the connotations with the weapons that are on screen now, but it's a pretty catchy name, and maybe it's even why some of you are listening to me right now, is that name. So that's the situation, we're living with it. But the drones we're talking about today really are looking more like this. If your organization has these, or you're thinking about integrating them, they're probably referred to as RPAs or RPAS, which stands for Remotely Piloted Aircraft Systems. These are multi-rotor aircraft. They typically have 4 or more electric motors, and they maneuver by changing the relative speed of those motors, which is actually a very interesting design because it means that mechanically they're really quite simple for what they can achieve. They're relatively inexpensive and extremely reliable. The maneuvering navigation systems, and it can be fully autonomous because it's basically just changing the speeds of those motors is really just electrical signals. So that autonomy is really the future of how drones are going to be employed in the workplace, and we'll come back to that. So what are drones able to do now? I tend to think of them as being pretty capable of doing almost anything. That's not necessarily the case yet. Battery life and payload capacity are very real challenges. So what they can carry is pretty limited right now. Maybe eventually drones will wash windows in tall structures and weld steel buildings. That's potentially possible, but for now they really just carry sensors and gather data. And that means they're generally useful for 2 things: inspecting stuff and creating digital versions of stuff. Okay, so hopefully that video is playing, although I'm not sure it is. Okay, so software can generate 3D models from drone pictures or other forms of data, like thermal cameras or LiDAR scanners. This is really good for understanding an asset holistically. You can see the structure all at once. You can manipulate it on screen, move it around, zoom in and zoom out. You could take accurate measurements from it over and over once you have that model. So that's very useful. This can be done from the exterior of a structure or inside a confined space. And these models can be survey grade when required. So land search is pretty widespread. However, 3D renderings generated by modeling software aren't really as high resolution as the original images. There's this pretty serious loss of fine detail. Generally, they look kind of like video games that I might have played when I was younger. That's the type of graphics that we're talking about. So to do a more detailed inspection, we really want to look at the original images. So with high resolution imagery, that is pictures or videos, we can detect cracking, pitting, failed welds, missing fasteners, all kinds of fun stuff like that. Okay, so just to put that into perspective, basically for, if we had something like a blockage in a pipe, we wanted to understand the geometry of that. We use probably 3D modeling. But if we wanted to look at something with a little bit more detail, like a crack inside a pipe, then we would be using the original imagery that came right out of the sensors rather than processing that with some software. So most of what we just discussed refers to visual data, but we can also equip drones with thermal cameras. And these can obviously detect hotspots such as electrical infrastructure, but they can also detect moisture abnormalities, gas leaks, and so on. Because thermal cameras are much less high resolution to begin with than 3D models, less high resolution than traditional visual imagery. 3D models with thermal data don't really entail as much loss of detail. So there's some great applications for those, including energy auditing of buildings. Basically, drones give us a lot of ways to get. Sorry, it looks like I've got some screen issues here. Okay. Okay, so usually we're thinking of flying drones as flying outdoors, but in public works, a lot of what we're going to be interested in is in confined spaces. So there are drones that are designed for confined spaces, and they have some pretty interesting design characteristics and capabilities. Drones typically hold their position outdoors using GPS, but in confined spaces, they cannot see the sky. Propellers are at risk of contacting obstacles in close quarters, and that would cause most drones to crash. Turbulence from the drone's own propulsion can actually bounce back and cause instability in flight. Darkness makes navigation difficult for the operator and makes it more challenging, obviously, to collect useful data. And then, of course, there are usually barriers between the operator and the drone, and that's going to reduce transmission quality, which has, of course, its own challenges for operating the drone. So these are some cheesy demo videos, and they show a drone that's designed specifically for confined space inspections and 3D modeling in confined spaces. As you can see, it has a cage that fully protects its rotors. It's actually also got a detect and avoid system that uses infrared sensors, and that helps it hold position even in GPS denied environments like indoors, underground, etc. That makes it easier to fly and, of course, avoids bumping into stuff. It's got a lighting system that can illuminate surfaces at oblique angles so that welds, cracks, pitting, and stuff like that is more apparent in the imagery that's collected. It's also got a LiDAR sensor on the front, which allows that to take real-time measurements between the drone and a surface in front of it. So it can easily measure, for example, in real time, the diameter of a pipe, and then knowing precisely the distance from the drone to that surface also means that after the flight is done, features such as cracks and other things can be measured very accurately. So this is typically used to inspect pipes, culverts, etc., with their relatively high diameter. And Rob and I have flown these things in some pretty hostile environments that are very challenging to operate in and just generally hostile to electronics. And fortunately, nothing too bad has happened yet. So this drone and others like it are capable of inspecting inside things like culverts, large diameter pipes, tanks, silos, cisterns, and so on. And these are generally places where it's dangerous or inconvenient to send people. But there are also machines that can easily go and inspect places where it's physically impossible to send humans. And that would be one of them. So Rob and I were invited here to talk mainly about drones, but I wanted to make the point that right now there's a similar evolution happening in ground robotics, where the cost and user experience is making them more and more accessible to contractors, governments, and industry. So why wouldn't we just use drones? Why bother with ground robots? Well, there are a couple of reasons. The form factor in design is much less constrained than it would be with a drone. And this snake robot here is a pretty good example of that. Generally, endurance is better also. So drones are typically being able to fly for 20 to 30 minutes, and ground robots typically 90 minutes or more of operation time. The one we're looking at now can easily inspect any pipe over about 20 centimeters in diameter. It's got its own lighting. It's got 6 cameras facing all different directions. So that means it can easily inspect the full circumference of a pipe in one quick pass. The tracks of this are also magnetized. So here we've got it going through a really tight structural member, just to give some perspective on how tight of spaces this can get in. It's shown here gripping a steel I-beam that can climb basically any heavy steel wall or a structural member. It can also travel upside down along the top of a pipe if that pipe is not dry at the bottom. So just further increasing the versatility of something like this. And this can be tethered or just operated wirelessly. So, for example, in a pipe that has lots of bends, transmission quality would be a challenge there, but a tethered system might work well in that case. Okay, so here's another robot which is now commercially available and is a recent addition to a repertoire at RMUS. You might have even seen this one on social media, for example. It's designed for remote inspections, but not really in confined spaces. This one's actually designed to work alongside humans in our typical everyday environments. So we might not see this one deployed very widely in public works, but this kind of represents the future of remote inspections, which is in automation. Just to briefly sum up what this can do, I'll give an example. This could live at a remote or inaccessible location in a weatherproof container, be woken up and then walk a pre-programmed route, inspect details as needed, detecting anomalies, and so on, then return to bed essentially in a charging dock at its home base. Then it would email a report to the relevant person, and that can be done on demand or according to a schedule and entirely without human intervention. So it can essentially autonomously detect defects. It can read things like analog gauges, or just identify that things are the way they're supposed to be and then report that autonomously. So very neat, and this is representative of the future here. There's one industry where the future, we're starting to already glimpse this future of drones and data analytics, and that is in wind power. And wind power is interesting for a few reasons. So wind turbine generators are, they vary in size, but they're extremely uniform in shape. So it's relatively easy to program drone routes that will autonomously fly a specific inspection profile to inspect these assets. And because the surface is all white, it's relatively easy for AI to detect and identify different types of damages. So right now, most wind turbines in Canada are inspected by drones who fly themselves and detected, classified, and reported automatically by software. Yeah, these assets lend themselves particularly well to this type of automation, and so they're kind of the first where we're seeing this type of thing happening. But I can very easily foresee a future where this type of automation in the data collection and analysis is pretty widespread, particularly for other relatively uniform structures like pipes, culverts, so on like that, perhaps even bridges in the not too distant future. So extremely interesting, and that's probably where we're headed as far as remote inspections are concerned.
Thank you very much for the presentation. It was very, very good, and we have a lot of questions already. So the first one, you mentioned when a drone measures something very specific, such as a crack in foundation, that there is a software used. What is the software and how does it work?
Well, the software I was referring to specifically in that case was it's post-processing software that's proprietary to that drone manufacturer. And the way measurements are taken is with so this is sort of a cliche term in drones, but photogrammetry is the analysis of photographs. And this has been done forensically by investigators like the FBI for a long, long time. It's essentially a form of trigonometry. So if we know very precisely the distance from the camera lens to a surface, we can determine how long, wide features in that image are.
Second question, how accurate is the land survey compared to a field survey?
That's an interesting point, and I would describe it a few ways. So using the best technology available, we can get land surveys that are required by a drone taking visual pictures down to a precision of about 1 or 2 centimeters. But I would also make the point that the data density is almost infinitely greater than surveys done with traditional means, where you might take a total station and shoot that at points 10 meters apart, whereas with the 1 pixel per centimeter or so of ground. So you can, rather than interpolating the distance between data points that are very sparse, you can detect features the size of for example, a clump of rock the size of a fist. You will see that.
And I just wanted to add to the first question there, some of the software that's used for some of this mapping is Pix4D, which is compatible with AutoCAD. So it's very useful for engineers to collect data and measurements and whatnot as well.
Thank you. And third question, can you generate a terrain model that can be applied to determining a watershed?
Sorry, could you repeat the question?
Sure. Can you generate a terrain model that can be applied to determining a watershed?
Yes, if I understand the question correctly, you certainly can. So DTM, or that's certainly one of the possible export files from this processing software. And many of them have a feature where you can simulate and see what sort of spread that would create over the terrain. Hopefully that's
Yeah.
at least getting at an answer to the question.
Approximate cost on a per square kilometer basis.
For a land survey of that nature, per square kilometer, let's see, between about 3,000 and 10,000, depending on the equipment used.
Good, that's good. I have a question myself now. How it compares to LiDAR? There is a LiDAR products. How do you compare to it?
That's a very interesting question. So first, I would make the point that LiDAR data collection from drones is possible and widely used.
Mm-hmm.
LiDAR is thought to be more precise because it has a much longer history of being used for aerial surveys.
Yeah.
The reality these days is that photogrammetrical surveys are nearly as accurate or as precise as LiDAR. And there are sort of different items in the error budget between both methods, but they're actually relatively similar.
Yeah.
The process of photogrammetry, combining a set of images, is relatively error-free. The problems are with localizing the aircraft at the moment that it collects the data. And that problem exists whether we're using photos or LiDAR.
Mm-hmm. Yeah, well, thank you very much. Any other question? Here, a fun question. You have no affiliation with the Skynet, right? From Terminator.
I've heard that one before, and I have to disclaim any knowledge of what Skynet is or any affiliation.
Yeah, no affiliation.
That's good.
Yeah.
Thank you very much, gentlemen.
Thank you. Thank you, everybody.
Thank you.
Okay, thank you for that. Well, we'd like to thank all of our speakers for taking the time to present these innovative public works solutions to help us celebrate Public Works Week. To show our appreciation, the Ottawa Valley branch of the OPWA is pleased to donate $150 to the Ottawa Food Bank to recognize the time and effort of all of our speakers today. So thank you very much. Hopefully you can join us tomorrow for another great lineup of presentations, including Ottawa U's work monitoring COVID in wastewater, roundabouts in Stormont, Dundas, and Glengarry, a look at the work at Montreal Road as part of the stage 2 of LRT construction in Ottawa, and a presentation about the Ottawa Valley Waste Recovery Centre. And also just a reminder that the OPWA is hosting a variety of events all week long, so the website should be up on the screen now. So thanks for joining us today, and enjoy the rest of your day.